Welcome everyone. Today I'll be presenting a paper titled AI is quicker and more accurate than pathologists at SNOMED coding pathology reports, published in the Journal of Clinical Pathology in 2026 by Mayall and colleagues. SNOMED coding is used in cellular pathology to categorize diagnoses. Each report receives a topography code and a morphology code. This study explored whether a fine-tuned large language model could automate this process, and the results are compelling. Here's the context. Somerset NHS Foundation Trust installed a new laboratory information management system in November 2024, but it had serious defects. Pathologists couldn't easily enter SNOMED codes while reporting. After about 5 months, over 15,000 reports were left without codes. Manually coding them would have taken roughly 465 hours, about 110 seconds per report, because the software required navigating through multiple screens with long load times. That would have cost nearly £70,000 in pathologist overtime, and the department was already understaffed. They needed a better solution. Now for the key findings. The team fine-tuned a modern BERT model on over 331,000 historic pathology reports to predict SNOMED topography and morphology codes. Looking at accuracy, and this is the standout result, human-coded reports had a 27.5% method error rate and 9.2% significant error rate. AI coding reduced both to under 1%. The difference was highly statistically significant, with a p-value below 0.000001. The AI was also dramatically faster, just 0.31 seconds per report, compared to 110 seconds for a pathologist. That's over 350 times faster. It processed all 15,238 reports in just 80 minutes on a standard CPU. And the cost savings are striking, around £4,000 for the AI approach versus nearly £70,000 for manual pathologist overtime. That's a 94% cost reduction. So what should we take away from this? First, accuracy. The AI outperformed human pathologists significantly, mainly because it didn't miss codes, duplicate them, or create contradictory entries. Its few errors involved rare conditions and reports without diagnostic conclusions. Second, efficiency. Processing all 15,000 plus reports took just 80 minutes on a standard CPU, no GPU needed for inference. With better hardware, it could be even faster. Third, scalability. While the model was trained on data from one department, the authors describe how other labs could fine-tune it on their own historic data, even using incremental learning where training data is limited. Perhaps most provocatively, the authors suggest that AI could eventually make SNOMED coding itself redundant. Instead of coding as an intermediary step, organizations like NHS England could deploy AI directly on full-text reports to extract whatever information they need, potentially with greater accuracy and granularity than any coding system allows. Thank you for listening. I'm happy to take any questions.